So the power supply wasn't gonna fit. And there it is right there. I'm just going to run an external. I put an extra pair of banana posts here for power for the unit. And these banana posts are for the meter in the front, voltmeter. But right now, I got them jumpered just so you can see it work. So this is what the idea I had in my head for terminals. These are all M6. And what I had to do was I had to look for, I guess they call them a nylon T-nut or something. And I couldn't find any in the United States. I had to order these from China. That's one of the things that took so long. So you can see that this goes through the metal skin right here. So the way I did this is I had to do this because it was this was too long and I didn't want to knurl it. So this goes on here like this behind the nut, and then behind that bolt it has another one of these and a regular washer. So if you look at it, this is what it is. Okay, so let's see if I can get this loose. So the metal is in that gap right there. And when I looked for these, I wanted to use M6 bolts. So I looked for some little M6 nylon. I guess they call it some kind of T-nut. Got them on Amazon. Took forever to get here. But if you look at the specs on this, that's a M6 hole that the bolt goes through. And I wanted it to go to M8. So the outer little sleeve of this fits in an M8 hole. So what I did is I drilled 4 M8 holes and it fits perfectly in there. Not too snug, but not loose at all. And then the wires inside this unit here, I had to bolt them like this, very tightly, because I wanted to ensure a good connection and not just depend on this to smash it down. So it goes through there, and we got a washer. Trying to do this one-handed with a stupid phone, so bear with me. And then this goes on the back wall. And then this, even with this washer right here, still sticks out enough when it comes out that wall, because the metal's thin enough that it fits in both of those. And then I put another washer like that, and then I tighten this thing down. And that gives me these terminal posts right here. And I tighten them pretty tight because this nylon stuff's pretty tough, man. It doesn't really flatten real easy or anything. So what I did on the inside there is I put a 10mm wrench and held those. And you can see they got the backing nut on them. And just torque down on these. And they're nice and snug. So when I wire the resistors to these, it's going to be R1, R2, R3, and R4. And when I wire the resistors to these, they're going to go on with another nut, and I'm going to hold back up on this. I'm going to smash them between this nut and another nut for good connection. So the way this thing works is you see all these relays in here. I got a little relay controller just because I figured these would pull a lot of current and that would be kind of hard on a little rotary switch contact. So on Amazon, I found a little 8-channel relay controller. And you may be wondering just what this diode is for. I got that diode reverse bias on there. the negative on the power input and the cathode, and the anode here. So it doesn't conduct with normal power. But what this diode's purpose is the inductive kickback off of these are sharing this voltage right here. And I just wanted to make sure I didn't get any high voltage inductive kickback on these little transistors and such in here and damage them. So right now with the green light on, none of these relays are energized. The green light just shows as power. And they have some little jumpers here. Let's see if I can focus in on it. And it's set to trigger high. So what that means is when I give this 12 volts, these little transistors are going to close each relay depending on the inputs. Or you could go low with it. You can put a ground. But I chose to go high with the voltage. So what we got here is this switch right here. So this is a 4-position rotary switch. And I'm really only using 3 of the 4. It's in the 4th position right here. And all I got that 4th position for is to disconnect and drop all loads, okay? Or turn off all the relays. So right now, I also got this in, this is going to be stereo mode. I'm going to try and get some labels made for this thing. And this is going to be mono for like bass amps and stuff. So in stereo mode, we're going to have 8, 4, and 2 ohms. And that's really all you need to test most modern stereos. I'm not going to do 16 ohms or anything like that. I could, but as you can see, I already got enough crap in here. So in stereo mode, when we turn that on, what it's going to do is going to configure 2 of the resistors on each side. It's actually going to series them. So with that on, these 2 are connected. So you got a resistor here and a resistor here. That's going to make 8 ohms. And one of the relays just shorts these 2 together to series them. And this goes to that negative terminal, and this goes to that positive terminal. Same thing here. It's just mirrored here. So now, when I go to that position, now it's going to be 4 ohms per channel. Okay? So what it does is I got a relay that shorts this positive lead going back to the positive to this resistor. And then this side goes over to the negative side, and this isn't connected. So it's just using one of them big 5,000 watt resistors for the channel. And it does the same thing here. So now, when I flip it down for 2 ohm mode, it parallels these 2 resistors. So these 2 are connected and these 2 are connected. And when it does that, my resistors are in parallel. So what that means is the positive is going to connect to this resistor and this resistor, and the negative is going to connect to this resistor and this resistor. So it effectively puts them in parallel. So the 4 ohm resistor in parallel with 4 ohms cuts it down to 2 ohms. So this does the same. So now you got 2 ohms per channel. And that's in stereo mode. Okay. And stereo mode really isn't doing anything right now. I just got it powering this little indicator light. It's not really connected to any relays. I do have a spare wire in here that I need to cap that off anyway. It really goes to this wire. So right now I was wanting to do like mono, I don't know, like 16 ohms or something, but I scrapped that idea because you don't really use 16 ohms unless you got like tube equipment or some guitar equipment or something. So if you would put this back right here and you put this one to mono mode, what mono mode does is these are still the same. Those 2 channels are controlled by these 3 resistors. It configures it for 8, 4, and 2 ohms. But this, relays. So this relay and the other one across from it, what it does, it just parallels these two outputs. So now if this is 8 ohms and this is 8 ohms, both of these are parallel. So you're just going to use one of these for mono. So if they're parallel at 8 ohms, now you got 4 ohms on this one. And if you put this on stereo 4, it parallels the 4 and 4, now you have 2 ohms, okay? And if you put this on stereo 2 ohms parallel with 2 ohms gives you 1 ohm. And I know what you guys are saying, in mono, I could go from here to here, like bridge, like on an amp, and that'll work. It's the same. These are parallel. It doesn't matter. But it's only going to run 1 meter, whichever one I'm on, okay? And if I put it across the whole thing, it's only going to run the meter that's on the positive, because these meters are both on the positive banana post, okay? And if I'm going in here, it's going to read on this one. So I kind of did that for a reason. Now it will read voltage across this, but since there's no current going through it, because it's kind of backfeeding this way to nothing, it shouldn't read any wattage. I hadn't tested it yet, but it shouldn't read anything, okay? Just the one where we're going to use the terminals for a mono load. And that's basically how this thing works. I mean, it's real simple. It looks complicated, but it's not. Lastly, you see these lights right here? It shows which relays are energized, okay? So these two are A, and it's going to do 8 ohms. All it does is series the 2 resistors, okay? And then if you put it in the second position, just these 2 B relays come on. And what it does is it just configures 1 resistor to the output, okay? But when I had this thing going to C, B should go off, right? Well, why didn't B go off? Well, I put a diode here, and I put it in such a way as when B is on, it won't flow a positive back this way, but when C is on, it will flow a backfeed a positive to keep this on. So what this does now is configure a channel for 2 ohms, okay? So effectively, it's just paralleling these two, all right? And these two right here are the mono, these 2 relays right here that just parallel the channels. So one is on both positives, on this positive and that channel positive, and they just connect them. And the other one is on that negative and that negative, and it just connects them. And they come on together, and I got them jumpered here. So the little 1 control input runs both of them. And when you go to stereo, you'll see these 2 drop out. But in stereo mode right here, it's on the 2 ohm position, and it's got all 4 of these relays right here running to parallel these outputs. And then if you just have B, B just configures one relay. It's like kind of like half parallel. It just drops 1/2 of the parallel. So the resistor right here, this is jumpered over to here, and the negative on the front's right here, and the positive on the front right there, but it's jumpered through a relay right here across 1 resistor. And y'all kind of bear with me, because I'm doing the best I can to explain this for anybody who's curious. And now look, I kind of did this on a budget. It's not the most beautiful. I went to Tractor Supply to get a little plate of aluminum. All they had was this diamond plate crap. And it's kind of thin, but I made a little platform here. And what this box used to be, y'all, this was a little 50 amp welding machine. And I bought this off of eBay because I liked the enclosure. And it had just had a big transformer on here, and it was on these legs right here. And I took the transformer out and I repurposed this for this. I built this little plate, and I just went to a hardware store. I didn't have any standoffs, so I used some little nylon spacers and put some little screws in there. And this aluminum soft enough they threaded themselves in there. And I got some more little standoffs under there, and what I got, I only had enough room to put 2 screws, and I'm going to show y'all the magic stuff. And I use this as glue, like my base knobs in my vehicle and stuff. Instead of drilling holes, go down to a hardware store or Raleigh somewhere and get this stuff right here. It's made by Permatex. It's called Right Stuff, and it's gray. It's a gasket maker, and I'll tell you what, this stuff, you could glue a brick to a wall if you could hold it there and let it dry overnight. I mean, it'll harden in about, I don't know, 90 minutes or whatever's on here, but it takes 24 to cure. And this stuff dries like a hard rubber. And I'll tell you what, I glued a base knob or 2 in a car with this. Just put a little dab of Pookie on it and put it in there and use something to hold it in place. And then later on, try to get it out. I was gonna break the damn car trying to get this out. You actually have to take a sharp putty knife and just kind of cut through there gently, and you'll eventually get it off. The good thing about this is, this doesn't damage cars, but holes do. So, if you just want to like temporarily have base and a year later you decide it's not your thing, like most people do, you could use some of this, and you can get it off. What I use is a real stiff plastic bristle brush, and you can kind of pick it off and use that little brush and just gently scrape it. You can get the little plastic, they got the plastic blade scrapers now, works real good. You can get this off with some patience. This stuff ain't gonna come off easy. Now this ain't really silicone, okay? And I don't think it's polyurethane either. Whatever this is fucking gangsta, man, because this is the best stuff I've ever used to glue stuff together. So anyways, sorry for the rant, but I got some Pookie under here. Pookie. And it's, I got some more little spacers. I just Pookied them on there. And man, this thing ain't going nowhere. I can move this whole thing. So that's what's holding that. And in fact, I didn't want to drill any holes for these transformers. They got Pookie holding them, and look how strong that is. And this thing probably weighs 20-25 pounds. It's pretty heavy with all this wire in here. I don't know, I have to weigh it. Maybe it's a little more or less, but it's pretty heavy. And all I did is put a little line of Pookie on there and let it harden for 24 hours. Look at that. Tell me that stuff ain't badass. Anyways, the little transformers are there, little donut transformers. And this is what's going to be measuring the wattage for the basic garage meters. And let's see. Under here, I drilled a hole with a little rubber grommet, and I ran all the wires in there. And this is just a leg off a resistor, and I just jumpered the remote connection to the positive, so it comes on immediately and stays on. But I just got a little hole with a rubber grommet under there, if you can see, on both of them, just to protect the wires going through here. And this thing had a bunch of painted silk screen writing on there. It was a weld machine, and I was going to sand it and paint it, but it had holes where the other stuff was. So what I did is I took a piece of that aluminum plate from this I got from our Tractor Supply, and I cut this with a miter saw. It looks like a chop saw. A skill saw comes down and goes back and forth, makes straight cuts. And if you get like a cabinet blade, and some of them even say good for soft metals, it will cut this real nice. Then I took this down to my buddy's shop, and we sandblasted it to get the shine off of it. And then I used some stuff called zinc phosphate or you can find zinc chromate. It's used for outboard engine lower units. And man, you put that on there with like a sandblast surface, that stuff will not come off, man. This stuff gets porous and it grabs paint. It's a real good primer. And I just used crayon black, just some cheap paint from the hardware store. And it did a pretty good job. Drilling this thing, I had a few moments. There might be a little nick or two I'll touch up later. But I put the diamond plate and the shininess, it was almost like chrome, man. I just thought that was too busy. And I like black is beautiful. So, these right here, I'm gonna have to make some labels and the mono stereo switch and turn it off. Also, I got these big 200 amp relays off of Amazon, and they mostly have good reviews. It's just like anything else you get in China. Some of them aren't going to work. I mean, a lot of this stuff is made in China, okay? And even the switches, I got all this from Amazon. And these bonding posts. And these are some pretty heavy bonding posts, but I discovered something about these bonding posts. This is like brass plated aluminum. Yes. So, you know, the little gap in there is real short. I think it does have actual brass screws, and I don't know if you can see, but I soldered them terminals to that thing with a big old soldering iron. Get the best connection I can. So I don't know if this is going to be a problem or not. If it is, we can I'll go to something like that through it. But like the AD1, the D-More Engineering AD1, if you look at that thing, it's got just some little shitty banana plugs that they, you know, like Big D and Steve Mead and all them are pumping all that power into. So I figured, what the hell, we'll try these. So the AD1 actually got little banana jacks like that, from what I can tell. You think that's going to handle 15,000, 8,000 watts? You think you're going to have a voltage drop? You think there's a lot of metal in that, behind that little banana plug? I think not. So I went ahead with these, and I bought some different banana jacks. I got some coming. They're the type that lock. It'll fit like an 8-gauge wire in it, and it's kind of like at an angle, and you put it in there, and it's got a knob, and you turn it, and it spreads the little plug in there, and it locks. So I'm gonna try those for more positive connection. But what I got was these. See, I'm getting one out with one hand. These will do 8-gauge wire, which is probably what I'm going to put on the amp anyway for testing. It says it'll do 8-gauge, and this is one of those little smash connection deals where you run the wire through there and you shove it up in there, and this thing just kind of smashes down on it. And they're pretty nice, you know. They fit pretty tight. But after I'd already ordered these, I saw them locking tight, man, where them things won't even move. So I'll get a good positive connection in my mind. So got those, and I also got these right here. Amazon's just treasure trove of this cool, cheap, Chinese-made stuff. And these are all right, I guess. I think these will fit 8-gauge too. You gotta look for ones that say like 10 and 8-gauge. So that's where I'm at. I finally got the wiring done on this, and I checked everything with the meter. It is switching properly, and also we have no ground faults. So if I go from the little strip hole right there, and as you can see, if I go to this one right here, I get continuity. But all these are seem to be good. So my little connection idea of this thing worked. And you know, banana plugs usually have something like this on there, but I've seen these little like T-type washers before. So I started looking for them, and I'll be damned, I had to order those from China. So I'll be making some, I'll probably use some little locking banana plugs on this to go to the power supply. The power supply, I'll probably mount it up under the fence somewhere. You can see the 4,000 or 5,000 watt resistors. And I got some number 2 wire, and if you don't know how big number 2 wire is, that is number 2 welding lead right there. And I got some lugs with 1/4 inch hole, and I'm going to wire this number 2 welding lead between this box and those resistors. And the reason being is you don't want any resistance for that distance right there. So you want your amp dyno to be as accurate as possible and hold 1 ohm, because those resistors get hot, and it's just the physics of things. As most metals get hot, the atoms get agitated and it creates some resistance. So nothing's perfect, not even me. I'll be the first to raise my hand and admit that. But it should hold pretty close at 1 ohm, and I'm hoping this relay thing will work out. I think it'll be okay. Took me quite some time to get all this in there. I just put some tie wraps to kind of keep this down so that when the lid goes on, it doesn't really press on it much. Nothing's really in the 9-line bind. I did turn the lugs to crimp them so the wire wasn't all twisting and trying to loop a knot. I know it's not the prettiest, but shit, it works. And we'll see till the next video. Still waiting on stuff. I got to get the 500 amp power supply mounted. I got to put a 50 amp 240 volt service. Still got to get a bunch of more big welding lead and a lithium bank down there, but I should be able to test some smaller amps with that 500 amp power supply. So that's all I got right now. Sorry for the video being so long. I'm getting ready to button this thing up. This is the cover that goes on it. So I'll just slide that on there. And it's got about 12 screws that hold this thing all together. But once you get it all screwed down, it all fits flush and nice. So anyways, y'all have a good week. And until next time, thanks.